Hello friends, welcome to chemistry lecture. I am Professor Makran Kulkarni. This is the lecture number 4 and the last lecture of topic lubricants. What you are going to learn in today's lecture: properties of lubricating oils. Remaining property we have to discuss like flash point and fire point, cloud point and pour point, annealing point and neutralization point, and the last topic, that is selection of the lubricant. So already we have discussed the different properties of lubricating oil. Let us start with the second property, flash point and fire point. What is my flash point? It is the lowest temperature at which the lubricating oil gives off enough vapors and ignite for a moment when a tiny flame is brought to near it. So when it is in contact with the tiny flame, at lowest temperature lubricating oil shows a vapors and ignite for a moment. That temperature is called as a flash point. Next is fire point. It is the lowest temperature at which the vapors of the oil burn continuously. See, after igniting for a moment, means after the flash point, it start the burning continuously for at least 5 seconds when the tiny flame is brought near to it. That temperature we have to calculate, or known as fire point. A good lubricant should have flash point at least above the temperature at which it is to be used. This is the Penske-Martin's apparatus by which we have to determine the flash and fire point of the lubricating oil. Look at here, this is a diagram of Penske-Martin's apparatus, and this is the actual photo of Penske-Martin's apparatus. Let us start with the apparatus. It consists of an oil cup, shutter, flame exposure device, and air bath and pilot burner. Let us start the first one, that is oil cup. Look at here, this is the oil cup in which we have to take oil whose flash point and fire point we have to determine. It is about 5 cm in diameter and 5.5 cm deep. We are talking about the oil cup. The level to which the oil is to be filled is marked inside the cup. Like this way, we have to mark here. It is shown here with to oil level we have to fill the oil. The oil cup has a lid and it is provided with the 4 openings. The one opening is for thermometer, one is for the stirrer, one is for just to pass the vapors, and the fourth is meant to be admission of the air, so through which the air is passed. Like this way the 4 openings are there. Second is the shutter. Look at here, the shutter is attached to the mouth of this oil cup. It is provided at the top of the cup. By moving the shutter, like this way we have to move the shutter, opening in the lid opens and flame is deep into the opening. So whatever the vapors are coming out this, if we open the shutter, that allowed to pass through this oil cup. Next is the flame exposure device. It is a tiny flame connected to the shutter by a level mechanism. This is a test flame which is attached at the mouth of this oil cup. When we open the shutter, that is open to the vapors of the oil cup. Next is air bath. Oil cup is supported by an air bath which is heated by a gas burner. This is an air bath. And lastly is the pilot burner. Look at here, this is the pilot burner. As the test flame is introduced in the opening, it gets extinguished, but when the test flame is returned to its original portion, it is automatically lightened by the pilot burner. This is the use of pilot burner. Let us start the working of this Penske-Martin's apparatus. First of all, oil under the test is filled up to the mark in the oil cup and then heated by heating the air bath by a burner. So by using burner, we have to start the heating the air bath. Ultimately the oil in the oil cup is get heated. Stirrer is worked between the test as a rate of about 1 to 2 revolutions per second. Look at here, this is a stirrer. So when we stir it, the oil gets moved and uniform heating is provided. Heat is applied so as to raise the oil temperature by about 5 degrees Celsius per minute. At every 10 degrees Celsius rise of the temperature, the test flame is introduced for a moment. Now what we have to do, just when we heat the oil in an oil cup, as a 10 degrees Celsius temperature when increases, we have to open the shutter, and by moving the shutter, whatever the test flame is there, that is introduced for a moment. The flame is introduced, whatever the vapors are coming out, at which, for example, the temperature at which the distinct flash is observed, that is a weak sound and light is appears inside the cup, then it is known as or recorded as a flash point. Immediately we have to close the shutter. Okay, so the temperature at which it shows the weak sound and light, that called as a flash point. Now thereafter the heating is continued and the test flame is applied as before. Again we have to heat the oil in an oil cup, and time to time we have to remove the shutter at every interval of the 10 degrees Celsius, and just we have to introduce the test flame. If oil ignites and continues burn for at least 5 seconds, that temperature we have to note down as a fire point. So by this way, by using a Penske-Martens apparatus, we can easily determine the fire point and the flash point of the lubricating oil. Next is cloud point and pour point. Cloud point: when an oil is cooled slowly, the temperature at which it becomes cloudy or hazy, it appears like cloudy and hazy, then it is called as a cloud point. And the temperature of the oil at which it does not flow in the test tube even when kept horizontal for 5 seconds is recorded as the pour point of the oil. So here we have to cool the oil. If it, after cooling at the temperature, if it appear like a cloudy or hazy, that is a cloud point. And if by keeping horizontal for 5 seconds, if it is not moved, then it is known as a pour point. Now what are the significance? Cloud and fire points indicates the suitability of lubricant in cold condition. Lubricant used in a machine working at low temperature should possess low pour point, otherwise solidification of lubricant will cause jamming of the machine. Now how to determine the cloud and pour point? So this is the diagram of apparatus. Let us start the working. Now apparatus consists of a flat bottom tube which enclosed in an air jacket. This is the air jacket in which the flat bottom tube is enclosed. The jacket is surrounded by a freezing mixture, ice plus calcium chloride. So surrounded by this jacket, this ice and calcium chloride mixture is attached or added, which gives the proper cooling to the oil. The tube is half filled with the oil and the thermometer is introduced in the oil. Look at here, the cork is attached. First the half, that tube is filled with the oil, look at here, and the thermometer is fitted. The temperature is start to measure. Now as the cooling proceeds slowly, the temperature falls down. Obviously, with every degree fall of temperature of the oil, the tube is withdrawn from the jacket for a moment and examined. I mean, just we have to keep it for 2 to 3 seconds, and just we have to take outside to measure, to examine. Now what we have to examine? Let us start. The temperature at which, as we discussed, when we have to after 2 or 3 seconds, every interval we have to keep outside this, we have to take outside this tube, and we have to examine. If it is a cloudy, that temperature is known as a cloud point. Now after cloud point, after this cooling is continued and the test tube is withdrawn after every 30 degrees Celsius fall of the temperature and tilted to observe the flow of or pour of the oil. Now the temperature, what will happen, the temperature will decreases up to 30 degrees Celsius and the temperature at which oil does not flow in the test tube, even kept horizontally for 5 seconds, it is recorded as the pour point of the oil. So by using this apparatus we can easily calculate the cloud as well as pour point of the oil. Now next property of the lubricating oil is aniline point. The minimum equilibrium solution temperature for equal volumes of aniline and oil sample is called as an aniline point. It indicates the possible decay of an oil in contact with the rubber, scalings, packings, etc. Aromatic hydrocarbons have tendency to dissolve natural rubber and synthetic types of the rubber. So we can easily calculate the aniline point, and it is essential as the rubber scaling we can, or for packaging we can easily use that oil as a lubricating oil. Next property and the last property of the lubricating oil is neutralization number, also called as a acid value. The extent to which either acidic or basic constituents are present in the lubricating oil is called as neutralization number. Means the acidity as well as basicity, means how much acidic or basic is the that oil, we can calculate in terms of neutralization number. Now lubricating oil should possess acid value less than 0.1. This is the standard value. If it exceeds this value, then it indicates that oil may undergo oxidation, and this leads to the corrosion of the machine parts. So before using the oil, such type of neutralization number is required to calculate, and by using this we can easily determine whether that oil is suitable for that machine or not. Now this is the last point of lubricating oil or lubrication, that is selection of the lubricants. Now as per the condition, the lubricants are used for the various purposes, like lubricants for cutting tools, example cutting fluids are used in machining, cutting, turning and grinding of the metals. Second is lubricants for internal combustion engine, which should possess the high viscosity index. Petroleum oil containing additives are used as a lubricants. Third is lubricants for gears, that also we have to see. We already discussed gears are working under the high pressure, and therefore lubricant should possess the good oiliness and high resistance to the oxidation, as well as they should have the high load capacity. Next is lubricants for delicate instruments. For example, delicate instruments such as watches, clocks, scientific equipments, sewing machines, etc. are used as a lubricants. So we can use palm oil, coconut oil in such type of delicate structures as a lubricant. Then lubricants for very high pressure and low speed, for example tractor, rollers, concrete mixtures. So solid lubricants used in such conditions, example graphite, then mica, etc. Next is lubricants for transformers. So when transformer is on load, some chemical changes may take place in the oil, so it may lead to the formation of acid and sludge, and refined mineral oils are used as a lubricant in such type of condition. And lastly, lubricants for refrigeration system. In refrigeration system, naphthalene based oils are used as a lubricants because they possess the low pour point, low viscosity and low cloud point. So by studying this, it is very easy for us to understand that where we can use which type of lubricants. So this is the all about the lubricants and lubricating oils. Thank you. Keep learning. Distance doesn't matter. Take care.